Hello everyone, let us start with our question. In this question, what is given? A particle of mass m, charge q, is moving in a region where uniform electric and magnetic field is given as to be E and B. Okay, these are present. Now E and B are parallel to each other. At t equals to 0, V naught velocity V naught of the particle is perpendicular to E, and we need to consider that speed is very less than c. Now find the velocity v of the particle in term at the time t, and we must express our result in terms of t q m vectors v naught v vector, e vector, b vector, and the magnitude v naught, e and b. Okay, now let us first of all draw our situation. What is the situation? So the situation is like this. So for example, if we draw our coordinate axis, so what are different values? So it is given that b e and b are parallel to each other. Okay, and at v naught is perpendicular to e. So we just define that. Let's say this is our x direction, this is our y direction, and this is our positive z direction. Okay, this is the case. Now let's assume that in this direction it is the particle which is moving. Particle is moving, let's say, in this direction initially. This is the initial part. Okay, now what would be the direction of our e and b? So e and b are perpendicular. Let us assume that e is in the vertical direction, also b is in the vertical direction. Why? Because e and b are parallel to each other. So we say that this is our e, this is our e, and this is our b, and this is our what? This is our v naught velocity. Okay, now what would be the value of v at any time? We say that v vector at any time would be equals to vx in I direction plus vy in j direction plus vz in k direction. Okay, we can write it like this. Now what will happen when the particle is moving? So for example, if there is no electric force, for example, let us assume for a moment that there is no electric force. So what is the direction of the magnetic force? So magnetic force, we can get the direction of magnetic force as what? F would be equals to q v cross b. Okay, q v cross b. Now what would be the value of v cross b? So v is in the x direction and this b is in the y direction. Okay, that means I cross j, I cross k is what? It is equals to k. That means at the initial instant the magnetic force would be in this direction. Okay, just at the entry. So magnetic force, this is the direction of our magnetic force. So magnetic force is perpendicular to velocity. Okay, now we have on the field. Okay, we have just on the electric field. So electric field would be in the upward direction. Now due to this magnetic force which is acting perpendicular to the velocity, so this particle will try to move in a circle. It would be moving in a circle. Okay, it would try to move in this circle like this. Okay, and due to electric field, so this circle, so gradually it will be moving upward. So its motion would be like this. So we just draw its motion. It would be it enters like this, but its motion would be gradually, it would be like this. Okay, circular motion is due to what? Circular motion is due to the magnetic force, and upward motion is due to what? It is due to the electrical force. So upward velocity, how can we get the upward velocity? Because in the upward direction it would be the electrical force which would be acting. So we can say that in the upward direction, we just say that in y direction, if we apply for y direction, we can say that acceleration in y direction would be the force in y direction divided by the mass. Simple. So what is the force which is acting in the y direction? It is just the electrical force which would be acting. So if q is the charge, so we say that it would be q into e divided by m. Okay, now if we apply our equation of motion, we say that at the starting, so it is not having any velocity in the y direction. That means velocity in y direction is 0. It is having velocity only in x direction. So we can say that at any instant of time, our velocity in y direction at any time would be equals to ay into t. That means qe divided by m into t. Okay, this we get the velocity in the y direction. Let us come to velocity in x and z direction. Okay, now let us assume that at any instant of time it has traversed a distance like this. It is moved like a distance z, this theta. So basically I'm just drawing it in the xy plane. So if we draw it in the xy plane, if we draw in the xy plane, let us select a plane. Let's say this is our xy plane, sorry, xz plane. So this is our x, we say that this is our x and this is our z. Okay, so we are viewing this from the top. If we view this from the top, what we see? So we see this type of a shape. So it would be just moving like this. For example, at an instant of time t, it is at this location. Okay, so if we draw, for example, from here to here, if we draw a perpendicular, if we draw perpendicular at this point, so from here if we draw a perpendicular like this, Okay, and from here, if you draw perpendicular like this, these perpendicular are drawn with respect to velocity too. So velocity is let's say v naught. So for example, if this angle is theta, so what will be this angle? This angle would also be theta. How? For example, if we draw a line, so this angle is theta, so it would be vertically opposite angle. This is theta, so this is tangent. So this would be 90 minus theta. That means this is theta. So what is the component of velocity in this direction? It would be v naught into cos of theta. What is the component of velocity in this direction? It would be v naught into sine of theta. Okay. So this velocity is in which direction? X direction. So we say that velocity in our x direction would be equals to v naught cos of theta I cap, and velocity in our z direction, because this is our z direction. Okay, it would be equals to v naught sine of theta into k direction. Okay, now we know everything, every velocity, just we wanted to know the value of theta. So what is the value of theta? So let's say theta would be equals to omega into t. We see that is if omega is the angular frequency, or it is the angular velocity of the revolution, then theta would be equals to omega into t. Now what would be the value of omega in case of a circular motion? So omega value, we know that it is equals to qb divided by m into t. So this is the value of our theta. So we know theta itself. Okay, we know the velocity. Now what is to be done? We just write the expression. So we are just writing the expression for our velocity vector. It is, we have just written vxi plus vyj plus vzk. Now what is the value of vx? Vx value we have just derived. It would be cos theta, and theta value we know that qb divided by m into t I cap. What is the velocity y? We have derived velocity y as it would be qe divided by m into t. So it would be qe divided by m into t. It is in the j direction, and velocity z, it would be v naught sine of theta. Theta value is qb divided by m into t in the k direction. Now what would be the, because we need to find, we don't need to find in terms of I, J, K, we need to find in the terms of given parameter, V naught, B, and these things. So how can we write our I vector? So I vector would be equals to, because we know that x velocity, this is in the x direction. So what we can do, we can just divide the velocity in the x direction, velocity in the x direction with the magnitude of the velocity. So what is the magnitude of the velocity in the x direction? It was, we just see in the initial situation. So velocity vector is given as to be v naught, and if we divide it by the mod, so it would be v naught vector divided by mod of v naught. So we can write our I value would be equals to v naught vector divided by mod of v naught. Okay, this would be the I. Now what would be the j? J, we can say that because in electric field is in the j direction, so we can say that j vector would be equals to E vector divided by mod of E vector. So this is how we write the unit vector. So this would be equals to E vector divided by mod of E vector. Okay, now how to write our k? Because it is also k cap. How to write our k cap? Now in the k cap, we see that this is our force. Force is acting in the k direction. At the initial instant, it is acting in the k direction. So what we can do? We can just divide our force vector with the magnitude of the force. So force vector is what? Force vector is q v cross of b. Now if we divide it by, this is basically v naught. If we divide it by the magnitude of this, so magnitude of this would be v naught into b, and q would be gone. So it would be v naught cross b divided by v naught into b. So this would be the final expression. So we just need to put the value of I here. So this is the final expression for velocity, where I is this, j is e by e vector by mod of e, and k vector is this k cap would be equals to v naught cross b divided by v naught into b. So this is all we have found. So hope you have understood this explanation. Thank you.
A wire loop carrying current I placed in xy plane as shown in figure. Now here, first part is if particle charge q and mass m is placed at center and given velocity v along np, find instantaneous acceleration. So here first part we have to find acceleration. Now second is the external uniform magnetic induction field V equal to vi gap is applied. So find the force and torque acting on loop due to this field. So here we have to find force and torque when acting this loop. So here we can talk about this. Now firstly, this is a loop and current I flow here, and whose point we have kept charge Q, and whose at point P its move NP direction on the velocity of B here. So instantaneous acceleration is equal to force. We have to find instantaneous acceleration. So force equal to Q V into B. This is a magnetic field. Now here we find magnetic field from this loop. So at a point P, so the magnetic field at point P, then M and arc because magnetic field. So here it is subtend is 120 degrees. So equal magnetic field of this circuit is comes. We can write M N arc equal to 1 by 3 mu naught I upon 2, and here a radius is given A. We can write here A. This is the out of the plane. So now here MN line. Now here magnetic field on a MN line. So we can write MN line equal to here. This is the distance at, and here it's the 60-degree angle. So this is the 60-degree angle. So MN line of this field magnetic mu naught I upon 4A cos. This is the cos 60 degree, and here this is a 60. So means a sine alpha plus beta. That means a 2 sine 60 degree. Now here we cancel this term 2. Here it is comes the u upon mu into I, mu naught I 2a tan 60 degree. So this direction is inward, and tan 60 is under root 3. Here now V net equal to 1 by 3 mu naught I upon 2a k cap. This is the outward direction. This is take outward, so means positive. And here mu I 2 under root 3a, and this is a k cap. Here means the inward, you take negative. So this is the negative sign. Now here calculate minus 0.11 mu naught I upon a k cap. This is the A means that this is A is a smaller, and here take a denominator. So this is all comes a negative. Now here force Fm force is comes a Q V V. Here we find because I put here value. So Q and V is now here we can take this V velocity move here. So take a elongation his side. This is a 60 degree. Now here we can write take a component like this velocity component, take this cos 60 degree I cap plus V sine 60 degree J cap into V net. So here we can write Q equal to Q V upon 2 I cap plus V under root 3 2 J cap cross minus 0, put the value of this 0.11 mu naught I upon a k. So here we can take this is the minus comes here. So here we take a minus. So this is a 0.11 under root 3 mu naught I upon 2a. This is a QVI. Now here this is a force come in vector form. Now acceleration. So acceleration equal to force upon m. So now here we can write this is a 0.11 mu I Q V upon 2am, and here component is j cap minus under root 3 I. So here we have find a force acceleration. First part is completed here. Now this is the second part. Second part say dipole find moment. Here external magnetic field, find the force and torque at the loop of the field. So here we take a dipole moment. Suppose this is the loop. This loop take find dipole moment of this loop. So current flow in this direction here, and here 120 degree angle. So this is subtended 120 degree angle. So here it is a 60 degree and it's a 60 degree. Current is the flowing direction. So here we have right moment, dipole moment m equal to I a gap. So now here area comes area equal to acceleration area minus a triangle area. So arc area is pi a q upon 3 minus a square upon 2. Triangle area sine 120 degree. Now here we write if this is a find, then we get a 0.61 a square. Now magnetic moment m equal to 0.61 a square. Because magnetic moment is I into area, so here a square I into k cap. Now we write this is a v. It's a given in a question v into I cap. Here torque. Now we can find torque. Torque equal to m into v. So here we can multiply this term 0.61 a square I k cap into vi. So here it comes up 0.61 a square I j cap. Here now we can find the solution. This is the solution. That is the torque acting on the loop due to this field. So this is solution of this question, guys. Thank you.